Assalamualaikum warahmatullahi wabarakatuh. Hello, greetings. My name is Reisya Putri Ariyan. ID number 22060591313. Numerical method class 05. Today is the part 2 of the final exam presentation of numerical method. And now I want to tell you about the study case that Padai gave to us is the about the spring mass system. Before this video, I already made the muhasabah video or measuring myself in this term. Okay, and first, I wanna introduction for the study case that Padai gave to us. The study case is the spring mass of vehicle in the mass minus the suspension and wheels or unspurred mass. For simplifying the suspension system analysis, we assume an even mass distribution and consider the system as one shock. So we should choose what is the best shock that um, after we calculate, we should choose the best shock for the spring mass system for the vehicle. And the Rockwell Collins Satellite Transportable Terminal or STT is a robust portable earth terminal used by the US Army for secure communication in challenging environment. So after this introduction, I set my intention for this study case is the goal of seeking Allah blessing through learning about numerical methods applied to military needs, so that we can be useful for society. So after we set our intention for all of this study case, we can move to the problem one. So the problem one, I set or I define the DAI 5 method or the framework thinking for every problem. So it much more detailed. The first problem is we have the intention to because we have the three different shock absorbers for the military trailer or STT loaded with a satellite by modeling the suspension system, analyzing damping characteristics, and comparing behavior to ensure safe transport. So the initial thinking about this problem is the first is critical damping analysis. The second one is system modeling, and the third one is differential equation solution, and the last one is comparison and analysis to have the what is the best shock that we get from the calculation. And the idealization that we have is we assume that and simplify the suspension, and the second one is uniform mass distribution, and the third one we can use the linear system like the external, so we negligible the external force. And the instruction, we determine the critical damping by calculate the beta C for a shock and compare giving damping coefficient to their critical damp values. And the second one is the model system. Third is plot solution. Fourth is analyze and compare. And the last one is conclude the best shock that after the model, plot, and analyze, we can conclude the best shock for the military needs. The problem too is we have the intention to determine the best shocks absorber for the suspension system to prevent the damage to the satellite by analyzing the system response to a specific force function. So we evaluate this shock based on their displacement behavior over time and recommend the most suitable option. So the second problem is like we have the shock, but we determine or we choose the shock based on their displacement behavior. So the initial thinking is we have four initial thinking. The first one is non-homogeneous solution. Second is we analyze the displacement and we recommend and we solve that homogeneous solution. And then the idealization is we simplify the model like the problem one, and we uniform force distribution too, and we use linear system. And the instruction, so the first instruction, we should solve the non-homogeneous equation. After that, we use that for the each for every shock, and plot the displacement by xt for each shock absorber. And then we analyze the displacement by determine the maximum and minimum displacement for each shock, and we present this value in a table and discuss the long-term performance of each shock absorber. And we recommend best shock based on the displacement analysis, and we solve homogeneous equation for recommended shock. So the third problem is to we have the intention that demonstrate to budget committee and undamped shock or premium shocks are insufficient for the STT suspension system by analyzing the system response to varying driving condition and illustrating the potential for damaging oscillation. So we have the two main thing is the budget and the response for the varying driving condition. The initial thinking is the variable frequency analysis. The second initial thinking is frequency impact after the variable frequency, and the third is invalid solution with the value of omega, and the last is interactive plot, so we can visualize the system response over time with varying the omega values, highlighting the potential for damaging oscillation. And the idealization we have is same with other problem. We simplify, we uniform force distribution, we initial condition use x0 as initial condition, and we use linear system too. So the instruction is more shorter than the other problems. We just use three instruction. The first instruction is solve variable frequency problem with the significant. We describe the significant omega in relation to vehicle speed and road roughness. It's very linear. And the second one is analyze solution validity to determine for which positive value omega the solution becomes invalid. When For example, like when displacement grows without bound or the system becomes unstable, and characterize the suspension system behavior at this critical omega. And the third one is we have the interactive flow too, so we can describe any potential damaging effect on the STT during transport. And the fourth problem is we have the intention that model and analyze vertical motion of an STT trailer when a mounted machine gun is fired, determine if the system will stabilize or lead to structure failure. So we use experimental data to estimate the damping coefficient and assess the risk of resonance orbits. So we have the consideration of this fourth problem is the structural failure. And we have the initial thinking that we should have the data plotting so we can visualize the displacement data to understand the trailer behavior. And the second one is damping coefficient estimation, and the effect is resonance orbit hypothesis, and the last is structural integrity assessment. And the idealization is same like other, and the instruction is we plot the data and describe behavior, and then estimate damping coefficient, use mathematical approach like maybe MATLAB or Python. Then we minimize the sum of square error or SSE to estimate the damping coefficient beta, and we evaluate resonant orbit hypothesis, like analyze the frequency of the external force and natural frequency of the system, and assess structural integrity, like determine if the displacement exceeds zero point 0.5 meters, indicating potential structural failure. And the last problem, we already in the last problem, is the fifth problem. The intention is analyze the STT trailer suspension system, respond to traveling over large terrain modeled by impulse function, determine if the chosen shock or extreme shock can prevent damage, and maintain structural integrity, like the combined problem 1 and problem 4 we combine in problem 5. The initial thinking is we have the initial value problem or IVP to formulate the differential equation for the spring mass system with impulse, divine variables, parameters, and initial condition. And we are using the Laplace transform solution to solve the IVP, using the Laplace to handle the impulse function, and with verification, the plotting with verification and plotting using Mathematica method like MATLAB or Python, and create the visual plots, and we analyze the displacement and structural integrity assessment. The idealization is same like other, and the instruction is we formulate first the IVP or the initial value problem, like we apply the Laplace to solve this IVP because we're using Laplace transform. Then we verify using MATLAB or Python, and then we analyze displacement we find the maximum and minimum displacement, and then we assess structural integrity, like determine if the displacement exceeds 20 centimeter, evaluate the effect of decreasing the time between impulse, and provide guidance on transferring large terrain with the STTs. So this is the framework from the spring mass system, and the next part is the last part. I demonstrate, or I'm presenting the um, we calculate with MATLAB or Python. Okay, thank you. Wassalamualaikum warahmatullahi wabarakatuh.